What type of energy involves the movement of the atoms or molecules that make up a substance? You just saw this type of energy in the simulation when you looked at the movement of those neon atoms. What type of energy do you think it is? Are you thinking kinetic energy because it says movement and kinetic energy is moving energy? Well, if you're thinking that, not quite. It is a type of kinetic energy, but we need to be more specific. The answer is thermal energy. Thermal energy is the energy in the movement of atoms or molecules, maybe they're water molecules, but the atoms or molecules that make up a substance. The energy of the movement of those atoms and molecules. In the gas, you saw they were moving a lot. In the solid, you saw there wasn't much movement energy there. So solids have less thermal energy. You might think of thermal energy like this. It's the total of all the kinetic plus all the potential energy in the movement of those atoms or molecules. Look at the two examples at the bottom. Which has more thermal energy? Well, they're probably both solids. I see that the movement is just kind of a vibrating in place, so not much thermal energy there, but one definitely has more thermal energy. It's the one on the right. The one on the left just has the thermal energy of two atoms. The one on the right has the same movement, but we have the thermal energy of all five atoms. Remember, thermal energy is the total of that movement energy. So five atoms have more movement than two. Look at another example. Which fire has more thermal energy? Well, the flames are the same color, so they're probably the same temperature. One fire isn't necessarily hotter than the other, but for sure there's more thermal energy in the larger fire because that has more atoms and molecules to move. Here we have snow. Snow is pretty cold, so not a lot of thermal energy there. Cold things have less movement in their atoms and molecules, so there's going to be less thermal energy. But definitely one has more than the other. Which would it be? You should have picked the snowman. There's just a lot more water molecules in that snow. Even though each water molecule barely moves, because we're looking at a solid here, that movement has a lot more total movement, total energy of movement, because there's just more molecules in the snowman.